All right, so when you have a polynomial, the first thing we do is factor out the GCF. That's what we've been doing. Then whatever's inside the parentheses, if it's something other than 1, whatever's inside the parentheses, you got to check and see if that can be factored further. All right? If you have 4 terms, you're going to try what? Group them. Grouping. If you have 3 terms, then you're going to try that trial and error, right? The 2 binomials that you've been working on in the last few worksheets. Okay. Now here's the next one. I want you to watch this carefully. What if you had this? What if you had x squared minus 9? So we've had this polynomial. First of all, what's the GCF? 1. GCF is 1. Why'd you say 3? Okay. All right. GCF is 1. All right. But is this a trinomial or is this 4 terms or is this 2 terms?
2 terms.
It's 2 terms. Okay. One of the things you did on that first worksheet that you turned in this chapter 13 was something like this. I asked you to multiply. Let's say you had x minus 3 times x plus 3. Okay? I asked you to multiply something like this. How did you multiply this? You FOIL. So you said x times x is x squared. The outer is 3x. The inner is negative 3x. And the last is negative 9. Then you did what? Combine like terms. Now when I combine like terms, the outer and the inner canceled out. And you're left with how many terms? And what are they? Which is what this was. So when you factor this, you'll notice that this right here, that's a difference, right? It's a difference. And I want you to know, to think about these words. This right here is the difference of 2 squares. Now we're going to talk about why this is the difference of 2 squares, but that is the difference of 2 squares. So the difference of 2 squares, first of all, you have to have 2 terms. In here will be 2 terms. And each term, you'll be able to rewrite it as something raised to the second power. And it all goes back to the idea of perfect squares. Remember your perfect squares from Math 97, 2 semesters ago, your perfect squares are something like 4. 4 is a perfect square because I can write 4 as what? 2 to the second power. 9's a perfect square because I can write 9 as 3 squared. 16's a perfect square because I write 16 as 4 squared. What's the next perfect square? See the pattern? 3 squared, 4 squared. What's the next one? 25. So I can write 25 as 5 squared, and so on. So all these are perfect squares. There's an infinite number of those. So a perfect square, you can always write it as some factor raised to the second power. Your smallest perfect square is 1, because I can write 1 as 1 squared. And 4 is 2 squared. So 4 is the only even number that's a perfect square. I'm sorry. Forget what I just said. No, what I meant was something else. 4, don't worry about what I just said. I wasn't even thinking what I just said. All right, 16 is a perfect square, so it's not the only even number. Okay, but difference of 2 squares. So I want you to notice, see that x squared minus 9? Whenever you're factoring, you first of all look for the GCF, then notice there are 2 terms, right? What do you notice I'm doing to this x? I'm doing what to it? Squaring it though, right? So think of the word square. So check and see, whenever that's the case, check and see if this right here is the difference of 2 squares. If it is, that means you can fill these things in. So you're going to rewrite it like this, and you can see what you can fill inside the parentheses. What times itself is x squared? X. What times itself is 9? So this is the difference of 2 squares. So the difference of 2 squares is where you rewrite as 2 binomials, and it looks like this. So this is, so you're going to say two binomials, and you're going to say x minus 3 times what? X, not minus, plus 3. See, if you did both minuses, you'd have a middle term. The middle term would be a negative 6x. So in order for those, see, there's no middle term. The x term's not there. So in order for that to happen, one has to be negative, the other one has to be positive. So then let's try this one. Now that you have that idea, what do you think, how can you factor, let's say, x squared minus 25? What do you think?
X minus 5, x plus 5?
Yes, x minus 5, x plus 5. So you go through the process. What's the GCF? 1. It's not a trinomial. It's not it's not 4 terms. It's a binomial. What sign is in the middle?
Negative.
Negative subtraction difference, right? I see an x squared, so let's check and see if this is the difference of two squares. So always check and see if the difference of two squares. So can I fill in these parentheses right here? What's in the first parentheses? What's in the second? Once I fill them in, I can now write as a two binomials. So what are the two binomials? What's going to be the answer? X plus 5 times x minus 5. And it didn't matter whether you said x minus 5 first. It does not matter. Okay? And remember, you can always check just like you did before. What's the outer? The outer? Negative 5x. What's the inner? They cancel out, right? And you're left with x squared minus 25. Okay? All right. Now let's look at these. Okay, so now that we know what the difference of two squares looks like, so there will be a formula sheet I'll give you for this. And really, it's very easy to remember what this looks like right here. But we're also going to talk about the difference of two cubes. That's a little bit more complicated to remember. And we're going to look at the sum of two cubes. So for the difference of two squares, it looked like this. I'm going to say f squared minus l squared. So do y'all see that's the difference of two squares? Right here? Difference of what? Two squares. So when I factor this, I'm going to say f minus l times what? F plus l. Okay? So whatever's being squared, in this case is x. Whatever being squared, in this case is 5. So you can say x plus 5 times x minus 5. So let's look at 48. Okay, don't make it complicated. Think about what we just talked about. Okay, that's what I have. It's not difficult. Think about what we just did. X squared minus 225 y squared. What's the GCF? 1. How many terms do you see? 2. What sign's in the middle? So what do you want to check to see for? If this is what? Difference of two squares. So in your mind, you're thinking this. Well, let's see if I can fill in these parentheses. Okay? Let's see if I can fill in these parentheses. First one's easy. What's going to be inside that first parentheses? X. All right, think about 225 first. What times itself is 225?
15.
Say it again?
15.
15? Okay. What about y squared? Y. So do y'all agree that 15y goes inside the second one?
Yes.
All right. So this is my F right here, and this is my L. So I found my F and I found my L. Now I can factor. What is the answer?
F minus 15y.
X minus 15y.
Sorry.
It's all right. That's y.
And x plus 15y.
That's it. There's your answer. Okay. So that was the difference of two squares. See how simple that is? Not difficult. What about 66? Can you do 66? Look at 66. A squared, B squared, minus 16. What's your GCF? 1. How many terms? 2. What sign's in the middle? Subtraction, difference. So what do you want to check for? difference of two squares. So if it is the difference of two squares, and it's always a good idea to rewrite this part, write this part. You don't have to, but it does help. What's gonna the last parenthesis is easy. All of you tell me what's inside the last parenthesis. 4. Good. What do you think is gonna be inside the first? AB. So here's your F. Here's your L. So what's the answer? AB plus 4. There's your answer. Okay. And if you FOIL it out, you can always check. If you FOIL it out, what's AB times AB? A squared, B squared. What's the outer? 4AB. And the inner is what? Negative 4AB. They cancel. And what's negative 4 times a positive 4? Negative 16. Okay? All right, let's look at 38. It's not difficult. 38. You have negative 9t squared plus 1. Negative 9t squared plus 1. All right. What may you want to do here? Okay, GCF is 1, but okay, so let's see what happens. See how he kind of, well, there's a negative out in front of that first term. But if you rewrite it, let's see if that makes it easier to deal with. If you rewrite it, put the 1 first, what does that become? And now you can see 2 terms. GCF is 1, 2 terms. What sign's in the middle? Negative. So you want to see this is the difference of 2 squares. So see, sometimes you may need to rewrite it. Rewrite the order. What goes inside the first parentheses?
1.
Okay, what goes inside the second?
3t.
All right, so there's your F, there's your L. So what's the answer? 1 plus 3t, 1 minus 3t. Okay, it doesn't matter. You can say 1 minus 3t first if you want to. Does not matter. Okay. 64. It's not difficult. Fairly easy. 169a squared minus 49b squared. Okay, tell me what to do. Always look at GCF first. GCF is 1. So you want to check, there's 2 terms, subtraction in the middle. So what do you want to check for? Difference of 2 squares. And it kind of gives it away because if you look at the exponent's a 2, right? In a little while, we're going to talk about the difference of 2 cubes. In that case, the exponent is going to be a 3. All right, but the exponent's a 2 here, so you're going to check for the difference of two squares. So in your mind, you're thinking this. Can I fill in those parentheses? What's the first parentheses? 13a. What's the second?
7.
Yeah, because 7b times 7b is 49b squared. So is this difference of 2 squares? Yeah. So you found your F, you found your L. So what's the answer?
13a.
Okay. Yep. So that's it. Okay.
So how did they know that it was 13? Because that would have taken.
13 times 13 is 169.
Yeah, but that's just like, they just know that?
Yeah.
There's not
Well,
any-
12 times 12 is 144, so I just went the next one up. Because 144 was, I figured it was close to 169, so I just went the next one up.
Yeah, you're just looking, see that 169, you want to see if it's a perfect square. We talked about perfect squares a while ago, right? Remember this right here? Your perfect squares? So we know that 144, like you said, is 12. So 12 squared is 144. And this is 169. So let's see if what 13 squared gives us. Well, 13 times 13 is 169. And that's our thought process. Okay, and so usually you got to remember in this section here, for the most part, they will be perfect squares. You got to figure out which of these integers times itself is that number.
What happens when it's not a perfect square?
We're going to talk about that in a little while.
Okay.
Okay. All right. So everything we've done so far have been the difference of two squares. So they've been perfect squares. Okay. Let's look at 50. 50. Okay, we have 32t squared minus 50. 32t squared minus 50. Okay, so right away you can notice the way it's written, it's not the difference of two squares, because no number times itself is 32. No number times itself is 50. Okay, but you got to remember the first thing you have to do always is look for the GCF. What's the GCF? 2. So you're going to say, all right, this is going to be 2 times what? 16t squared minus 25. Okay? Just like you did in the past, though, you got to look at the parentheses and ask yourself, can I do anything more with it? So here's my parentheses right here, 16t squared minus 25. What do you notice about that? Okay, so what you're trying to say is that right here is the difference of two squares. So because I can write this as 4t and 5, right? So this little part here that was inside the parentheses, I can factor this as 4t plus 5 times what? Okay, but don't forget, that's not the answer to the original problem. So in the blank, don't forget the GCF. So what's the answer? 2 times. Yeah. Okay. So that's where we had a GCF that you had to kind of do first. A GCF other than 1. What's your question? What's your question? What's wrong?
Where did the 2 go?
Where did the 2 go? It's right here.
Oh, that's the answer on the left.
Yeah, right here.
Okay, I couldn't see you write it.
Oh, yeah. So this is the answer. No, the right is that parentheses right here that we factored further.
Wait, I thought we needed to put a 2 somewhere.
Yeah. The GCF is always part of the answer. Okay, that's the answer. All right, let's look at 52. 52. All right, 52. You have 36x squared y minus 25y. It's not a difficult section. It's fairly easy. This is not difficult. You just got to remember your steps. What's the first thing you have to do here?
Take y out.
GCF. So it's y times, the GCF is y, right?
Yeah.
So you're going to say y times what?
36x squared minus 25.
Okay. So is that the answer? No, because you have to notice that binomial that's inside the parentheses, that's still, I can factor this because that's the difference of two squares. So here's your work, and you could do this in your head, but here's what you're thinking in your mind. Is what I have. My first parenthesis is going to be what? 6x. My second parenthesis is going to be 5. So now I'm going to say my factoring is 6x minus 5 times 6x plus 5. And so therefore my answer then will be what? Y times 6x minus 5 times what? 6x plus 5.
Okay, I have a question.
Uh-huh.
When I'm working mine, I work it down, and I constantly bring my y down. Is that wrong? Like when I'm working it, if you were to look at this, looking at my work, to give me credit for my work, would you mark off?
I'm not sure what it looks like. What do you say? You constantly bring it
Well,
down.
like, for instance, this
this?
Yeah, I already have a Y on that, and then I have a Y on the next one, which is, I mean, pretty much.
Oh, so you're saying something like this?
Yes, and then the Y there.
Oh, that's
Just
fine.
because I don't wanna,
No, that's okay. Just make sure you have Y and then that's still in parentheses or brackets.
Okay.
Okay? That's fine. All right. 56. 56. See, it's not difficult. It's fairly easy. So this is the difference of two squares. You have x cubed y minus 4xy cubed. X cubed y minus 4xy cubed. What's the GCF? Okay, xy. So that's going to be xy times what's inside the parentheses?
X squared minus 4X,
Ah,
no, Y squared,
4y squared, right?
right?
Okay. And then if you can really look at this and see how to factor that binomial, but if you need to rewrite it like this, and then in your mind, you're thinking about, well, what's going to go inside that first parentheses? What's going to go inside the second? 2y. So that means I can factor this as x minus 2y times x plus 2y. And that's going to go here. So let's give you my final answer.
X, Y times X minus 2Y. X plus 2.
Okay. All right. Okay. So now we saw a while ago that we used this example earlier, x squared minus 9, and we saw that was I could factor this because when I factor this and I used the FOIL method, FYL, I ended with this again. Okay, so this right here was the difference of two squares. But what if I had this? What if I had x squared plus 9? Not x squared minus 9, but x squared plus 9.
Signs would be positive?
Okay, so let's look at that. Let's look and see. So you're saying you think it's x plus 3 times x plus 3. Is that what you're saying?
Mm-hmm.
Okay. That's what most people would think of when they first look at this. So let's FOIL it out. Let's FOIL it out. What's f? X squared. What's the outer? 3x. What's the inner? 3x. What's the last? Plus 9. Combine like terms. What do I get?
X squared plus 9X.
6x plus 9. Is that what I want? No. So x squared plus 9 is not this. You want to try something else? All right. So you're saying one's positive, one's negative? Well, let's think about that. I got, well, two negatives. Okay, let's think about that. X minus 3 times x minus 3. What's going to be down the inner when you combine them? Negative 6x, right? The on the inner is going to be a negative 6x. Is that what you want? No. Want to try something else? What do y'all think?
X squared?
Say it again. You can't factor that. So this right here was the difference of two what? Squares. This is the sum of two squares. The sum of two squares cannot be factored. Can't be factored. So remember we did some trinomials earlier, not today, but in previous lessons, and when it couldn't be factored, you said what? Prime. Okay? So if you look at number 42, you have 49y squared plus 1. You still got to look at the GCF, because if it's something other than 1, you can still factor it by taking out the GCF, which was one of the worksheets that you got back today. So what is the GCF here, though?
7.
GCF,
One.
1. Okay. Now notice, how many terms do you see? 2. What's the middle sign? Plus, so addition. So you want to see, is this the sum of 2 squares? You're not going to say difference, because you know it can be difference, because this is not subtraction, this is what? Addition. So then you want to ask yourself, all right, is it the sum of 2 squares? If it is, it's prime, cannot be factored. Okay? So is that the sum of 2 squares? Yes. And the reason we want to ask yourself that is because there's also something called the sum of 2 cubes. The sum of 2 cubes can be factored. Sum of 2 squares cannot be factored. Okay? So is this the sum of 2 squares or the sum of 2 cubes? 2 squares. So since this is the sum of 2 squares, you'll see it's the sum of 2 squares, right? Because just like we were doing, what goes inside that parentheses here?
7, 1,
What goes in here?
1.
1. And the sum of 2 squares cannot be factored. So you say prime. Okay? All right, now, okay, so let's look at this one, because you could see something like 36 on my math lab. And even on a worksheet. Looks like this. 100 minus 2 squared. All right. What's the GCF?
1
1. 2 terms. What do you see in the middle?
minus
Subtraction. So let's see if this is the difference of 2 squares. Is it? Yeah. What's the first parentheses?
10.
What's the second?
2.
All right. So now you got to write in this order. So what are you going to write it in? 10 minus t times 10 plus t. So the reason why I did that one is because everyone we've done so far, the variable has been at the first term listed. So this is a situation where the variable is the second term listed. Okay? All right. Okay, now let's look at 70. 70. Don't make it difficult. It's fairly easy. You have 100 minus 4 divided by 81 n squared. Don't make it difficult. Same idea. Just happens to be a fraction. What's the GCF?
1.
1. What's the middle sign? Subtraction. So you want to see this is the difference of 2 squares. So if it is, I can fill in these parentheses. The first one's easy. What's the first one? 10. Now start with 4 divided by 81. What times itself is 4 divided by 81? 2 divided by 9. Okay, so then don't forget the n squared. So it's going to be 2 divided by 9 what? N. So now you know your answer. What's the answer?
10 minus 2, 9, 10 times 10
Yep, there's the answer. Okay. So it's not difficult with fractions. You can do that. Okay. Now look at this one. This is number 54. You have 25y to the 4th minus 100y squared. 25y to the 4th minus 100y squared. The GCF, if you do the GCF right away, 25y squared, right? Okay. Times what? Y squared minus 4. You all agree? All right, now don't forget, some of you are gonna stop there. You're not gonna get your full credit. You'll get some, but you won't get all of it because what do you notice about y squared minus 4? It's still the difference of two squares. I can factor it further. So now y squared minus 4 is easy to add. You can do it in your head. So that's the answer will be 25y squared times what two binomials? Yeah, y minus 2 times y plus 2. Okay. Now, I just want to remind you about something. Here's what someone else could have done. They could have said, all right, I can take out a y squared. Y'all agree? Take out a y squared. And then what will be inside the parentheses?
25y squared minus 100.
1 is 100, right? Okay. But then notice that inside the parentheses, that's the difference of two squares still. Because 25y squared minus 100, yep, is 5y and 10, right? So I can factor this as 5y minus 10 times what? Okay, so here's what you're going to do. You're going to say, all right, my answer is y squared times 5y minus 10 times 5y plus 10. Okay, and some of you will do that. You will say, you will think only about the variable, take out the y squared. But then you got to remember what we asked ourselves. Is inside the parentheses, is that still prime? Is GCF 1?
No.
What can you take out? A 5. What about this? What can you take out? A 5. So here's what you're doing. You're saying, all right, I can still take out a 5 here, so I can write this as y squared times 5 times what? Y minus 2. And over here I can take out a 5, and then that's 5 times what? And then 5 times 5 is 25. Put that in front. And so you get 25y squared times what? No, I'm just saying though, it's going. There's going to be a situation where you're not, and you saw that in some when we did the grouping or something else where you forgot to take out the GCF. You still were able to factor it, but then that one of the factors, the GCF was not 1. You had to take that out. But yeah, it is a lot easier if you take out the GCF at the beginning. So when you did your problem, Stephanie, the worksheet, you took out a common factor, but what was in parentheses, you could still take out some more. So you should have taken out more, okay? And that's the situation you would have here. Okay, look at 46. Okay, so that's what I have. Into the fourth minus 16. Is that the difference of two squares? Well, first of all, GCF is what? 1. So let's see if I can fill in these parentheses. 16 is easy. What goes here? 4. What times itself is into the fourth? N squared. So into the fourth minus 16 is the difference of two squares. So I can factor this two binomials. And my two binomials are? Okay, so that's where I'm at, okay? And if you're not careful, some of you are going to stop there because that's what we've been doing. We've been stopping there. But notice that every time we did it, n minus 3, the GCF here is 1. GCF here is 1, right? 10 minus t, GCF is 1. 10 plus 2, the GCF is 1. Here, GCF is 1, GCF is 1. Here, y minus 2, y plus 2, the GCF is 1. Now, if you did it this way, the GCF was not 1, it was what? 5. And 5 here, so you take them out. So here, though, n squared plus 4, you notice that this is the sum of what? 2 squares. Can I factor that further?
Yes.
Sum of 2 squares?
No.
No. Remember a while ago we saw the sum of 2 squares cannot be factored. Okay? Remember that was a whole discussion a while ago. Right here. You remember that? All this? That's what that was. Cannot be factored. But what do you notice about this? Say it again? You can, because that's the difference of what? 2 squares. So you always want to see if you can go further. So notice that this is 2 squares, so I can factor this further. So how many binomials will be my factors in this answer? 3. So it'll be n minus 2 times what? N plus 2 times what? N squared plus 4. That will be your answer. Okay? So you got to check and see if what's inside the parentheses can be factored further. So the sum of 2 squares cannot be factored. So you stop there with that part, but the other parentheses was the difference of 2 squares. So we can factor that further. So again, it's kind of like he had this. Let's write this as an example. Suppose you had x to the 4th minus, let me say, I don't want to use 49 because it's not going to work with what I want. Let's say 81. Make this 81. X to the 4th minus 81. 81. So is that the difference of 2 squares? Yes, because I fill in these parentheses, x squared and 9, right? Okay, so that means I can write this as x squared minus 9 times what? X squared plus 9. Okay, is that my final answer? No, because I can go further. Now, don't forget that second parenthesis, that second binomial, that's the sum of 2 squares. I cannot factor that. But the first parenthesis, that first binomial, that first factor, that's the difference of 2 squares. So I can factor this further. How can I factor that? No, not 9 and 9. 3. X minus 3 times x plus 3. And then the final factor is x squared plus 9. Okay. So that's the difference of 2 squares and the sum of 2 squares. That's all that is. So it's easy to deal with. Not difficult. Okay? Now, look at this. Okay, so let's suppose we had this polynomial. We had this polynomial. What's a GCF? 1. What sign do you see in the middle? Negative, subtraction, difference, right? So is this a difference of 2 squares? No. For one thing, that x is not being raised to the second power, it's being raised to the third power. So then you want to ask yourself, all right, since x is being raised to the third power, let's see if this is the difference of 2 cubes. All right, so let's talk about cubes, perfect cubes. My first perfect cube is 1, because 1 cubed is what? 1. My next perfect cube, 2 cubed, is 8. 8's a perfect cube because I can write it as 2 to the third power. The next perfect cubed, 3 cubed, is what? 27. So 27 is a perfect cube because I can write it as 3 to the third power, and so on. Okay? So you want to see this is the difference of 2 cubes. So again, just like we were doing with the difference of 2 squares, in your mind you're doing this instead. Not to the second power, but to the what? Third power. So what's going to go inside that first parentheses? X. What's going to go inside that second parentheses? 2. Okay, good. So this is my F, this is my L. All right, now here's how you factor the difference of 2 cubes. Now you don't have to memorize this formula, I'll give it to you. But F cubed minus L cubed is a binomial times a trinomial. That's how you factor. It'll be a binomial times a trinomial. The binomial, see how this is f cubed minus L cubed? The binomial will be f minus L. So whatever the first parentheses is minus whatever that second parentheses is. F minus L. So it's a binomial times a trinomial. The trinomial is this. Whatever f is, you're going to square it. Plus, so there'll be an addition, plus. Then you're going to take the f and the L and you're going to multiply together. Plus, and then you're going to take the L and you're going to square it. So that's your formula. So you can see how it's going to look with this one. So it's not difficult. You just got to remember that formula. I'll give it to you. You don't have to memorize it. But if you multiply a binomial that looks like this and the trinomial looks like this, when you multiply this thing out, it will be the difference of two cubes. All right? So look how this is going to work out. What is f in this case? X. What's L in this case? 2. So think of this as terms of f and L. Okay? So all you do is plug it back into your formula. So remember, it's a binomial times a what? Trinomial. The binomial part's always the easiest because you just write what you see. What's L? I mean F. What's L? So what do I write? X minus 2. So there's your binomial. Now let's talk about the trinomial. So the trinomial says this. Trinomial says I take f and I do what to it? Square it. What's f in this case? So x times x is x squared. So that's x squared that goes there. Plus. Then it says I take f and L and I multiply them together. What's f? X. What's L? So what do I get? 2x. Okay? Plus. Then it says I take L and I square it. I multiply it by itself. What's L in this case?
2.
So what's 2 times 2?
4.
4. So there's your answer. It turns out, though, you remember how when we did all those problems before, we always asked ourselves, can I factor this further? First of all, can I factor x minus 2 further? That's easy to see you can. This trinomial, some of you can be trying to factor this. It cannot be factored. So this trinomial right here cannot be factored. So don't even try doing this. It cannot be factored further. You're done. This is it. Now, if you want to check and see, now on a test, you don't have time to check this. But let's see if this is actually the answer. Let's just check it. Okay? So here's how you check it. You take the first term here, multiply by this trinomial. And you take the second term and multiply by the trinomial. So it's kind of like distributive property. So it's kind of like, I just want to relate it to this. I just want you to see that what we're doing here is mathematically correct. Suppose I had this. Okay? We did this by FOIL, right? But even before you did this with FOIL, you also saw that you could have done this using distributive property. So in other words, you could have said x times this parentheses plus 5 times this parentheses. So in other words, I'm saying x times what? X minus 8 plus 5 times what? X minus 8. And then you distribute. So x times x, x times 8, 5 times x, and then 5 times negative 8. And I want you to notice that if I FOIL it, what's x times x? X squared. What's the outer? That's this right here. What's the inner? That's this right here. And what's the last? That's the FOIL. Okay? So you would get x squared minus 3x minus 40. Okay? Same idea here. So you're going to say x times what? Yeah, x squared plus 2x plus 4, correct? Minus 2 times what? X squared plus 2x plus 4. Remember, all I'm doing is checking, just to show you that now on a test you just stop there because you don't have time to check. So this would be the answer. But if you want to check to see if what you have is correct, this is what you would do. Because you can't use a fall method here. Fall method only works if you multiply two binomials. So you have to use this approach right here that we're doing. So distribute. What's x times x squared? What's x times x squared? X cubed. What's x times 2x? 2x squared. What's x times 4? Okay. What's negative 2 times x squared? What's negative 2 times 2x? Negative 4x, right? What's negative 2 times 4? All right. Combine like terms. Have x cubed. I want you to notice 2x squared and negative 2x squared is 0. 4x and negative 4x is 0. And all you're left with is what? Negative 8, and that's what you wanted to factor. See it? So the difference of two cubes can be factored as a binomial times a what? Trinomial. And that's the formula. Now remember, all we did here was just check, just to show you that if you were to use distributive property here, you would get what you want, x cubed minus 8. All right? So it's not difficult. It's just a matter of you doing like we did, find f and L, and then plug it back into the formula. So let's do another one with that. So let's look at this one. So suppose we had, write this example, suppose we had 8x cubed minus 27. 8x cubed minus 27. What's the GCF? 1. How many terms do you see? 2. What sign's in the middle? Negative, subtraction, difference. You see that x? What power do you see? Cube. So are you going to want to check and see if this is the difference of two squares? No, because you know it's not going to be the difference of two squares. But it may be the difference of what? 2 cubes. Okay, so let's see if it is. So I check to see if I can put something in those parentheses. Last one's easy, last parentheses. What's going to go inside that last parentheses? 3. What about the first? 2x. Y'all agree? So is this the difference of 2 cubes? Yes. So here's my f, here's my L. All right, now let's talk about the formula. So the formula, remember, was f minus L times f squared plus fl plus L squared. Y'all agree? You don't have to memorize this. I'll give it to you. You just got to plug things back in. All right, so here we go. What is my binomial in the answer? Very good. So all of you should be able to give that binomial. That's the easy one. Okay, now let's do the trinomial. So the trinomial says this. I take f and I square it. So in other words, I multiply by itself. So let's think about this. What's f in this case? 2x. So I'm doing f squared, right? So I'm saying 2x times itself. What's 2x times 2x? 4x squared. So that goes here. Okay? So f squared becomes 4x squared. Because 2x times 2x is 4x squared. Plus, so then I take f times L. What's f in this case? 2x. What is L in this case? What do I get when I multiply them together? So that goes here. Okay? See, in your mind is what you're saying. Sometimes it helps if you write it out, though, what I'm doing here. Then the last one says L squared. So that means I take L, and what's L in this case? 3, and I multiply by itself. And what do I get? So that goes here. And there's your answer. So you factor this. Remember, factoring is just writing things as a product. So I factor this binomial. It's a trinomial, well, trinomial times a binomial. That's all it is. It's not difficult. Okay. Let's look at this. Let's see. Okay, let's look at one more. Now we're going to do the sum of two cubes next Thursday. We'll do, and I can't assign that section because we still have the sum of two cubes left to talk about on my math lab. Sum of two cubes to talk about, and then what's called a perfect square trinomial. That's all we have left. But it's not difficult. Fairly easy. You can do it. And I don't have the worksheets for this either because I wasn't able to print them out. So I won't give it to you until Thursday. Okay, so let's look at this.
So are these on our test?
No, your study guide, remember your study guide stopped at 13.2. This is 13.5 slash, and the way your book, for some reason your book has the difference of sum of two cubes in an appendix. So it's in appendix A1. So 13.5 is the difference of two squares, and appendix 1 is the sum and difference of two cubes. So A1 is appendix 1. And that starts on page 1222.
Yay.
So appendix 1 is on page 1222. And that's the one that talks about the sum and difference of two cubes. (13.5) is the difference of two squares, then a sum of two squares. That's 13.5. So let's do another difference of two cubes, and then I'll give you, remember that's this worksheet that I said I wasn't going to give to you until today? So I'll give you that. You can start working on that. That's from 13.3. But remember, your test only goes up to 13.2. All right, so this is going to be number 6 on page 1223. And here's number 6. 6r cubed minus 162. All right, so try doing that on your own. See how far you can go. And then and there's some candy up there if you you get stressed out. Some candy up there, just go and get some candy.